Okay, let's do a quick review of the concepts covered in exam 1, and then you can ask if you have any questions. So, first thing important is that please have your color highlighters or pencils or pens, whatever, with you, just to identify nodes in a network. The next important thing is the definition of series and parallel connection. So it is easy, but if the circuit is complicated, you sometimes forget what it is, and you end up just making wrong assumptions for different resistors combinations. Remember, for series combination, they are connected in one end, one terminal, and there shouldn't be any branches coming out from between them. Or if they have the same current in a mesh or loop, meaning that they are in series. For parallel combination, it means that they should share both terminals. And to determine mesh, you always go clockwise, this is something that we've worked a lot, so I'm guessing there shouldn't be any problem here. These two equations very important. Equations relating the current and charge. Now, under what conditions we use the first one, the top one? For which type of problems you go for the first formula? If Q is given to you, if charge is given to you and they ask for current, you go for the first one, right? And can you tell me what is the equivalent of taking a derivative when you have a plot? Say it out loud. Slope, right? So if you have a plot and you're supposed to find current based on charge, then you have to calculate the slope. You might get questions about units. So for example, every quantity, almost all quantities have SI units. For example, for current, it's amperes, okay, amps. But also you can find other units based on the equations that they are defined with. For example, you can say that another unit for current is coulomb per second based on that equation. Now, what if current is given to you and they ask for charge? Okay, then you should go and use the opposite of that equation, which is the integral equation. Remember, for the integral equation, you always need some initial value, which is given to you in the statement of the problem. For example, if the statement of the problem says Q of 0 is 5 coulomb, it means that your initial time is 0. Okay? Then your integral should be calculated from 0 to a point where you're interested in. For example, if they give you the value at 0 and they ask you the value at 5, the integral should be calculated from 0 to 5 plus the value at 0. Okay? And what is the equivalent of integration when you have a plot? Area under the curve or under the function. The one important thing is that whatever you have below the horizontal line comes with a negative sign, and whatever is above the horizontal line or x-axis is with a positive sign. Okay. You definitely get questions like that. We have done multiple of them on your web work problems, in-class assignments. We did even a couple of them in class. So I hope you're prepared for these types of questions. You have the next very important concept in electrical engineering is voltage. What is the single most important thing about voltage? It's relative. It should always be measured between two nodes or between two points. So can I assign voltage to individual nodes on a circuit? Or no? Can I assign voltage to individual nodes on a circuit? Yes, there's a big if. If you have a reference voltage defined, otherwise, no. Okay? So you set your ground or your reference, and then you can assign individual voltages. This is an equation relating energy, charge, and voltage. Okay? Just memorize this because you might get some conceptual or very easy calculation questions from this. And yeah, W is, which is energy, is equal to QV. Okay, now, what is the most fundamental definition for power?
It's work over time.
Yes, that's the most fundamental definition of power. The time rate of change in energy or work, which is dW over dt. If you look to the left, you see dW over dt, right? That is the fundamental equation. Now, what is the most important equation in electrical engineering for power? IV, right? So whatever you want to find the power of, you have to have voltage and current and then multiply them. And for example, if you get a question and a plot is given to you that represents the energy of an element, how do you find the power at some specific time? You don't have the function, you have the plot. No. You have the energy plot, and they ask you to find power at a specific time. What is that called on a plot? A slope, okay? So this is not something that you can nag me later about not being part of electrical engineering. This is like a prereq math problem, okay? So if you have the energy plot, it's very easy to find the power. It's just a slope. The opposite, if you have the power plot and they ask you what is the energy stored between 5 and 10 seconds, what do? Find the area between 5 and 10. Okay, integrate it, which is the equivalent of finding the area. Now, VI is the most important equation for power, and it can work for every electrical element. One thing that is very important is that a specific type of power may be asked, you may be asked to find. For example, you may be asked to find the supplied or the absorbed power. Now, if the current enters the positive terminal, I enters from the positive terminal of V. Then if you multiply I and V, it will give you the absorbed power. The opposite, it will give you the supply power. If the current enters from the negative terminal, it will give you the supply power. Now, there is some confusion, especially when negative sign is involved. Now, I want you to understand, I and V are some labels. They could be created by you or by the problem, by whoever gave you the problem, okay? It doesn't matter. As long as there is a label for I and there is a label for V, and I is entering from the positive terminal of V, if you multiply them, it will give you the absorbed power. Am I talking about any negative sign or so? No. So do I care if I is negative? No. Whatever the value is, just put it inside the parentheses and multiply it. Okay? That's one issue. I need you to focus on the labels. Okay? The label I is entering from the positive terminal of the label V. You multiply them, it will give you the absorbed power. Now, the next question. What if my absorbed power is negative? What does it mean? It's actually supply. Okay? So that's where the negative sign comes to play a role. I'm sure you're familiar with the shape of these, with the symbol of these creatures. One important thing about dependent sources is that this usually happens a lot. So let's focus on this one. I want to calculate its power. Absorbed or supplied, doesn't matter. So in order to calculate power of any electrical element, I need V and I, right? Which one do I have now? I, okay? I don't want to get confused and say we have the V and it's equal to Vx. Okay? That's where the confusion comes from. Especially for these two, the one with the check marks, right? Because the value of the element depends on its current, but it depends on voltage, it creates some sort of confusion. So this is what I ask you to do. Whenever you see dependent sources, first just focus on what type of element it is. What type of element that is? Current source, okay? So whatever is written beside that should have the units of amps, okay? And I don't care what it is, it's just a value. The important thing is that this is a current source, and that is a voltage source. Next question that could be given to you is that, what's the units of, for example, R? Sorry? Yes, volts per amps, or ohms. What's the units of G? Conductance. Well, conductance is not a unit, it's a quantity. Moles or Siemens or ohm inverse or 1 over ohms or amps per volts. Okay? Any question? Ohm's law. Very important, very useful. V is equal to Ri. Always? No. Only if current enters from the positive terminal of V. Okay? Now, one important thing. What is V? In the Ohm's law. In Ohm's law, V equals Ri. What is V? Voltage drop, voltage change. It's not either of the terminals' voltages. It's the voltage between the terminals. Okay? Very important. What if the current enters from the negative terminal? Then the Ohm's law requires a negative sign. This is another equation, the structural equation for resistor, which is resistivity length divided by area. Remember that the inverse of resistance is conductance. Okay, sometimes we prefer to work with that. And the units are in Siemens. Okay, so if you get a question that the elements are conductances with values in Siemenses, you have multiple options. I usually prefer to change everything back to resistance and work with them. Okay. Now, what's the definition of KVL? The algebraic sum of voltage drop around a loop is equal to 0. And whose child is it? KVL. Whose child is it? Who is his parent? No. There's a fundamental law in physics that actually the parent to this. Conservation of energy. Do you guess why? How? How is voltage related to energy? Do you have an equation for that?
Yes, it's voltage.
W is equal to QV. Do you remember that? So if the sum of the voltages is 0, it means the sum of the energies are 0, which means the conservation of energy. Okay? How about KCL? What's the definition of KCL? the sum of the algebraic sum of all the currents entering a node or in parentheses exiting a node. Stick to one of them. Is equal to 0. And what does that mean? What if it is not 0? What?
Currents being supplied to
Okay, what is the nature of current?
current is electrons.
Charge, right? Charge moving. So if KCL doesn't hold, it's violating some fundamental rule. Conservation of charge. Because let's assume something like that. Here, imagine there's a pipe coming here, bringing some water, and then going that way. So you say the water is coming from right and going to the left. Now imagine that there is no pipe coming from right to here, and just water is coming out of air. So it means that the water is being created. Okay? Now for charge, if KCL doesn't hold, it means that at some node, the charge is either being created, generated, or being destroyed. And that is violating the conservation of charge. So I want you to remember, KVL, conservation of energy, KCL, conservation of charge. Okay? If resistors are in series, just add them. If they are in parallel, use that equation. If you have only two resistors in parallel, you can go for the easier one. Product over sum, which gives you the parallel. What is the general equation for power? VI. How about if it is a resistor? V squared over R or RI squared. Remember, only for resistor. Not for a voltage source, current source, or anything else. Only for a resistor. Does it matter which direction current enters or exits? No, because both I and V appear with a squared version, right? So it doesn't matter. And does it physically make sense that it doesn't matter which direction current is entering and always your power is positive? Why? Resistors always absorb power. They cannot supply power. Okay, how do you combine voltage sources? So for example, to the left side, you have 4 different voltage sources. This is how I do it. So they are in series, right? Do you agree that they are in series? Do they have to be beside each other, or there could be something between them? It could be something between them. Still, they are series. If you remember the lecture that we talked about series, I told you if A and B are in series and B and C are in series, it means A and B and C are in series. So all the voltage sources are in series. You can combine them, right? You are allowed to combine. How do you combine? Draw one voltage source with whatever polarity that you want. It doesn't matter. Okay, for example, I went for positive top, negative down. Now compare the equivalent source with every single source and determine the sign. For example, compare the, let's call this guy VEQ. Compare the polarity of VEQ with V1. Are they consistent? Yes. So V1 in the value that you write here should appear with a positive sign. Now compare it with V2. Is it obvious that it's opposite or no? If you don't see that, I am asking you to do this. Mentally, okay, move that to where you can align it with the way that your equivalent voltage is. Like this. Is it in line with equivalent voltage source? No, it's exactly opposite. So that appears with a negative sign. So what I do in my head is that move it and then bring it near close to V1. So they are all following each other, and then say, okay, this is not as my equivalence. So it comes with a negative sign. For current sources that are in parallel, you can also add them. That's usually much easier. You decide on the direction of your choice. for the equivalent one and then see which ones are exactly in that direction, which ones are not, and decide on the positive and negative side. Voltage division and current division, very useful. As I said it many times, these are not required, okay? You don't have to know them to solve something, but most of the time they save you a lot of time. So remember the equation for voltage source and current source, and most importantly, remember when you can use them. If you have a problem, I did a review on them, I think one lecture after introducing that concept. I gave you a couple of cases where you can use or you can't use voltage division. In order to use voltage division, the resistors must be in series. In order to use current division, the resistors must be in parallel. Okay? And pay attention to the directions and polarities of the voltages. For example, if the voltages are defined opposite of the blue labels on the first circuit, then you need a negative sign in your voltage division. Superposition principle. What is the keyword? What is the keyword that you know you should use superposition? Contribution. Contribution. As soon as you see that, it's superposition. Okay? So, for example, I have 5 different sources, independent sources, okay, in my circuit, and I ask you to find the contribution of the voltage source, the 3-volt voltage source, to the variable or to the quantity Vx. What should you do?
You should replace all voltage sources with
No, not all.
all that you're not looking at.
Yes. Get rid of everything else. Get rid of every other independent source, except the 3-volt voltage source that you want to find the contribution. How do you get rid of the sources? Voltage sources should be replaced by piece of wire, short circuit. Current source, just remove the branch. Remember, if you're removing the branch of the current source, everything that is in that branch should also be removed, including resistors. Okay? I mean, I shouldn't say anything about this. Just look at it, okay? Beautiful, isn't it? Remember, this is super important, okay? If I want to ask you, when do you need it the most? Writing what kind of equation you need this guy the most, the blue box? Writing KCL at nodes, okay? So remember that. Something that sometimes students have problem is dealing with these guys. So for example, let's say this is 5 and this is 3. What is V2? It's V1 minus V, right? Remember that V, any voltage, how do you define a voltage across any element? Positive terminal minus the negative terminal. How do we do nodal analysis? First, open the box of the highlighters that you have, okay? Use the colors, identify the nodes. A ground, you need a ground. Then label the nodes. I recommend using your own labels. Do not get confused by the labels already printed on the circuit. Okay, use your own labels. Then you write KCL at each node using the box, the blue box. Which condition should you have in the circuit to consider supernode?
Voltage source,
voltage source shared between two nodes, okay? Then you have to use supernode. So when you're writing supernode equation, remember, you write one equation for the two nodes that are connected to the supernode, okay? So one equation. But you need another one. Where does that come from? Inside the supernode. What if one of the nodes is ground? Do I consider that a supernode? No, because the other node is automatically known to you, right? Yes.
And then all parallel elements.
Yes,
We also,
exactly. Everything that comes in parallel with the voltage source goes inside the supernode, which means they don't contribute to your KCL equations. And you remember why. Because one appears with positive sign in one equation, one appears with negative sign in the next equation, and if you add those equations together, they cancel it. Okay? This is how I actually proved that for the first time in class. Mesh analysis, the important thing to remember is that always label your meshes clockwise, okay? And you move in the direction of the current. What is the voltage drop across a resistor? IR, okay? So remember, because you are moving in the direction of the current, the voltage drop is IR. How do you write a KVL term of an element like this? How do you write it? If you're moving around the loop like that, how do you write the voltage drop across this element? Plus Vx. Do you have any other option? No. Because if this is a resistor, R, you can use also Rix. But sometimes it's a voltage source. Voltage source is pretty easy to write, right? You can just write it as plus minus. Because you're entering from the positive terminal, you can just write it as positive Vx. Or sometimes you are interested in including that voltage in your equations. Okay? For example, the only thing unknown in the circuit is the voltage across this guy, and you want to somehow include that in your equation. Then it's better to use its voltage. You should be familiar with the definition of practical voltage source and practical current source, which is ideal voltage source in series with the resistance for practical voltage source and ideal current source in parallel with the resistance for practical current source. And you know that you can just transform between them. So source transformation, when is that required on your first exam? Which I hope you know that it's tonight, right? Okay. When is that required?
Completely separate from that. How late are you up to be sending out that email at 11:34 p.m.?
Do you consider that late?
Well, I'm up at 4 a.m. for work, so yeah, that was late in the day.
Oh, I sleep around 1 a.m. I go to sleep around 1 a.m. and I wake up around 6 a.m. Yeah. So that's why I look dead. Yeah. Well, this is an announcement. I mean, I don't require you to respond to it. And I'm guessing that you should be able to see it the first thing in the morning. So it's fine. And you don't get any buzzing sound, I hope, from your cell phone. It doesn't disturb you. One time I actually responded to a student email at 2 a.m. and I think he mentioned it as a very positive point in my evaluation. Yeah. So that's something that usually happens. How do you, that was my question. When do you need source transformation on your first exam?
We don't.
Well, first of all, sometimes you may find it useful to simplify the circuit. That's not required. But there is one specific problem that actually it is required. I mean, you have to do it. Yes, maximum power transfer. Now, I have some comment on that, okay? Let me get to that part and I will talk about it. Yes?
I don't have a question.
Okay. So you know how to transform sources. If you have a voltage source, how do you transform it to a current source? First, check the condition. Can you or can you not?
It's a resistor in series.
Yes, it should be coming with a resistor in series. Then you can divide it by the resistor. It will give you the current source and bring the same resistor in parallel with the current source and vice versa. Now, the questions that involve maximum power transfer usually require you to do source transformation, because otherwise you won't be able to use the theorem, right? Remember, the maximum power transform states that if you have a voltage source, only a voltage source, one, in series with a resistor, and then some RL, then you are allowed to use the maximum power transfer. So if something strange is connected, something complicated is connected to RL, what is the first step? To simplify the rest of the circuit and get to a point where you only have one voltage source in series with the resistor or one current source in parallel with the resistor. Now, yes?
Would that be like possibly multiple iterations of going from current to
Exactly.
back?
Yes. This is usually how it works. You go from voltage source to current source, then combine some resistors, back to voltage source, combine some resistors, back to current source until everything is done. Okay? Usually you get two questions for this type of circuits or problem. The first one is, what should be the value of RL to receive the maximum power? Then you simplify the circuit until you single out one voltage source and one resistor, and then the value of RL should be equal to RS. The next question is, how much is the power, the maximum power? Then that is the second equation, the second formula. Vs squared over 4RS. Okay? I'm done with the review. Now, am I done? Yes. Before continuing, instead of doing source transformation, there is one more way that you can actually change any complicated circuit to this. You're not supposed to know that, but somehow you do. Am I making sense to you or no? Thevenin. You're not supposed to use that, but who's there to judge, right? If you find it, if you're comfortable with Thevenin, it's not part of your first exam. If you're comfortable with Thevenin, okay, and you can calculate it, then I usually find it much easier than doing source transformation back and forth. Just an idea. Yes?
You did superposition to get contribution. Would the same formula still work if you just added up all the powers from each one?
If you do a full... No. Do you know why?
Because it's squared.
Superposition comes from a very important property of circuit, which is called linearity, right? Is power a linear equation? No. So if you want to do that, you should first find the voltage add the voltages, find the full voltage, then apply the power formula. Because superposition and power equations don't come together. Okay, any questions from the past exams? Yes?
I don't know if you can work the problem, but in the 2022 exam,
2022?
yeah.
Okay. Fall, which,
Yeah, fall. It was like problem 21. You know, but, you know,
is it here? Let me see if the other section asked it or no. It's not this one, is it?
that's it right there. Yep, that's it.
Okay, so it's there. Voila. So, okay, so find voltage Vx. So which one do you choose? How many ways do you have to handle a circuit?
You did KVL.
No, don't say KVL.
Oh, yeah. I did mesh.
Mesh. Okay, this is not mesh. This is mesh. I actually did it both ways. So this is mesh. So 3 meshes, right? Look at the equations to the top right. So for example, do I need to write equation around I1 or no? Why not? Because there is a current source in that mesh. And current source dictates the current of a mesh. So you don't need to write a KVL around it. In fact, you can't, because you don't know the voltage across that creature, right? So I is equal to 3Vx. That's my first equation. Can you write a KVL around I2? Yes. I3? Yes. So look at these. See, I did this just to make it a little faster. Do you see what I've done here? Instead of writing I2 minus I1, I've directly written 3Vx instead of I1. So I technically substituted. Okay? So I have 2 equations here. Where does the third equation comes from? Because I need the third one. Because I need because I have 3 unknowns. I2, Vx, and I3 are my unknowns. I completely got rid of I1 because I substituted that. So my third equation is always where your Vx is. Where is Vx? This is actually a very good question. Where is Vx, guys?
Vx is down there.
It's not there? This is the wrong answer. When I ask you, or when you ask yourself where Vx is, it's there. Okay? That just depends on Vx. Okay, give me 1 second. Then, is there any relationship between Vx and I3 that can serve as my third equation? I3 is entering from the negative terminal and it's a resistor. So negative 9 I3 is equal to Vx. So 3 equation, 3 unknown.
Yeah, we messed up. You didn't do a mesh for the top.
You tried writing a mesh? Okay, can you write a mesh? Can you write KVL when you have a current source? No, because there's no way you know the voltage across a current source. Okay? Now, here is some comment on that. This is the first question, and you solve it and you find I1, I2, and I3. Based on that, you can find Vx. Do you all agree with that? If you solve the circuit, I want you to understand what solving a circuit means. You have 2 options, nodal, mesh. What does solving a circuit means? Either finding all the currents or finding all the voltages. We used mesh, so we should have access to all the currents I1, I2, and I3 right now. So we can find Vx. Good. Now, usually this is followed by this type of equation. What is the supplied power of the ugliest creature here? What is the ugliest creature here? The dependent source. That's where you get confused. Okay? So what is the supplied power of that guy? How do you handle it? I need you to remember the basic equation that you have for power. Vi. Which one do you have? Is everyone okay? You have I, okay? Some value. So what do you need? The voltage across that. I've labeled it as V3Vx, just to be consistent with the element. Now, who gave me those terminals? The polarities. Myself. I just labeled it myself. Is there any specific reason why I did label it in this way?
Matter because you squared it in.
No, that's not a resistor. It actually matters a little bit. Look at the number 23. Do you see the bold part? Supplied. So the way I've defined the polarity, if I find V3Vx and multiply it by the current, it will directly give me the supplied power. Am I making sense to everyone?
Because
Okay.
it's entering the negative.
Because it's exiting the positive or entering the negative term. Okay, so that's why I labeled it this way. Now, the question is how to find the voltage across a current source. I was just talking to him and I said there is no way that we know the current source. I said there is no way that we know the voltage across a current source, right? But that was before solving the circuit, guys. Now we are at the third questions in this series. We already did solve the circuit. So now we have access to all the currents. So what does that mean? It means that the only thing that I don't know in this circuit is V3Vx. Look at the pink loop. If I write a KVL around the pink loop, what is it? I think I wrote it here. Do you agree with that equation? Negative V3Vx plus 17I1 plus 8 plus 22I1 minus I3 plus 2I1 minus I2 is equal to 0. Now, do I know I1 and I2 and I3? Yes, because I just solved the circuit. What is the only unknown in here? V3Vx, you can find it. You might ask, why did I go for KVL? Any cue for that? Why did I go for KVL? Because I'm looking for voltage. The V in KVL is for voltage, right? What if I wanted a current? I would have written a KCL. Yes.
I forgot my question.
Sorry. That's all. Any other problem? This was pretty easy. I don't know. Some student was confused about that, but it's good to find it. This one also probably worth talking about. So it is asking for the current flowing through the circuit at t equal to 8. So what is the equivalent of, okay, first of all, which one is given to you? Q. So you want current. What kind of equation is that? Derivative, right? What is the equivalent of derivative when you have a plot? Slope. Find the slope at 8 seconds. How do you find the slope at 8 seconds?
Since it's a straight line.
It's a straight line. It's a line. So it doesn't matter whether it's 8 seconds, 9 seconds, 10 seconds, 7, 6, 5, 11. All of them have the same slope. So just go for the start and end of the line and find it. Okay? This was superposition, as you can see, contribution, okay? That wasn't a difficult. If you haven't already checked it, then I don't know why they are here, probably for last year. Yes?
Are we gonna have a question like on the web where it would be like a circuit and then there'll be an element or an element that's A, and then there's like different parts as to what we, like it would be like a
Oh.
resistor one time, a current source.
I'm not sure. But what's wrong with that kind of
I'll
question?
just-
I'm not sure. This is what I do because I want to be fair to students. I don't look at the questions before the exam. Okay? So I can give you a general and not biased review. Okay? Otherwise, my students would usually do better than compared to other sections. This year, it's only, both of them are my sections, but anyway, I'm used to doing this, yeah. But anyway, I expect your section to get a higher average than the, honestly, I didn't tell that to the first section. So don't think of me as some politician who says that just goes with the wind. No, I'm telling you this. I expect your average to be higher. Any more questions? Sorry?
Prepare to be disappointed.
Why? I'm always prepared. No more questions?
Yeah, I do.
Yes.
Could you go to the review problem on 18? When you go to the document that we would go over in the beginning of class, you have practice problems at the bottom of it. The one thing that, wait, no,
This one?
yeah, would you, and if you're trying to use mesh with the,
Oh, that's a good one actually. Yeah.
with the IN, would you just put that as I1?
Okay, let me see. This is super easy actually, but for some reason it's confusing. Okay, we want Vx. Okay, what do you suggest, Anna? Mesh.
You can combine your resistors.
You can combine the resistors, can you? There is something strange about this circuit, and I want you to be able to see that. What is that?
The thing in the middle?
Okay, what is that?
Oh, that's an open circuit.
It's nothing. It's just some labels to show you where Vx is measured between, which two terminals or which two nodes the Vx is measured. So you have actually one whole loop.
Why is it there?
Huh?
Why is it there?
To show you where Vx is measured between. Remember, voltage always needs to be measured between two terminals, right? So, what should I do? I mean, no matter what that thing is, we should be able to solve it. Yeah.
Can we add all the resistors, the 1K, 3K, and 10K?
If you add all the resistor, what's going to happen? What's wrong with that? Okay, Vx is defined for a specific node, and if you combine the resistor, you are destroying your knowledge of Vx.
You could add the 1 and 3K.
Yes, 1 and 3 is just, you can add them. Yeah.
Can you do a KVL from 15 volts to 10 and then go over VX?
Perfect. Do you remember, this is something that I insisted a lot on. If I want to write KVL around something, does that need to be a closed circuit? No. In order to define voltage, you don't need elements, you don't need wires. So this is how I would do it. And just, this is not about electrical engineering, but why did I include that?
Do what?
Why did I choose this loop or mesh for my KVL? Why didn't I write at the big one?
Because we already, we can simplify all those individual voltage drops too.
No, there is something wrong with going for the big one. You don't know the voltage across the current source, so you should avoid that. Right? Do you know what's the voltage across the current source? No. So I'm trying to bypass that. But is that current source giving you any information actually?
Yes.
Yes. The whole current of the circuit is 3 milliamps. So when you're writing KVL, you should write it like that. Negative 15 plus 10 times 3 plus Vx plus 1 times 3 plus 3 times 3 is equal to 0. One equation 1.
Did you write that out?
Yes. Negative 15 plus 10 times 3. Let me write it. Negative 15 volts plus 10 kilo ohms times 3 milliamps plus Vx plus 1 kilo ohm times 3 milliamps plus 3 kilo ohms times 3 milliamps equal to 0. One equation, one unknown. Done? You still have problem with this? No? Yes?
Can you do the one that's right under that, 31? With the, it has a different circuit.
What one above that or
No,
under it on the
the next one, the next circuit under it.
oh the in the exam file?
Yes.
Oh okay. I thought in the review file.
No, in the review file.
In the review file?
Yes, sir, sorry.
This one?
No.
Okay, let me remember what that is. The power supplied by the dependent current source in the circuit shown below is closest to. What should you do? I wouldn't go for nodal.
Why not?
Let me see. Ground 10. No, actually it doesn't matter. Both of them give you the same amount, same number of equations.
You think mesh would be better for it?
I would personally go for mesh, yeah. Because let me do both of them for you. I'm not going to solve it because you need calculator, but I'm guessing if you get to that point and you mess it up, you deserve to see me next quarter. So let's, which one should we go first? Nodal, okay. Then I have this guy. I have this guy. Of this guy. Where is my green? I don't have green. Blue. Okay, that's enough. So I'm assuming this is 0, this is 10, and let's call this one V1, V2, and V3, right? So where should I write KCL at? Can I write at V1? No. Why not? Because it's a supernode, right? So you should write at V1 and V2, supernode. V1 minus 0 over 14 plus V1 minus V3 over 9 plus V2 minus 10 over 19 minus 2Vy is equal to 0. Anyone having a problem with this? That's my first. What is, where should I write the next one? At V3. So at V3 is V3 minus V1 over 9 plus V3 minus 10 over 8 plus 3 is equal to 0. Right? That is 2 equations. How many unknowns do I have so far? 3 unknowns, right? V1, no, actually 4. Vy is also there. Okay, now, can you do something about Vy to get rid of that?
Yes.
How?
Vy would be V3 minus V2.
Vy is equal to V1 minus V2.
Wouldn't it be V3?
No.
It's in the top right node and the bottom left.
Sorry. The thing that I was insisting so much, I did it myself. Where is Vy?
It's
I don't see that. Oh, yeah. Vy is equal to V3 minus V2. Thank you. Yeah. What else? 3 equation, 4 unknowns.
4ix is V1 minus V2.
4ix is V1 minus V2. You add 1 equation, but you also add 1 unknown. What else?
Why don't we plug in Vy into the first equation and then do a KVL around either V1 or V2? Or no,
Yes.
The one you added,
Oh, yeah.
got rid of.
You could do.
Okay, let me ask you this. You wrote everything that you could, okay? Before talking about this, question 31 is the last question on the exam. I can't remember if it has more points or no, but it's usually the most difficult, okay? So, is there anything we can write about IX?
Yes.
So right about I.
Which I? What do you mean I?
IX is the kind of going into the tenfold.
Okay, how can you write an extra equation about that?
Did you say ix plus 3m minus 2vy is 0 because of the ground, so that it should have a.
Come again?
Do like a KCL from.
Yeah, write a KCL there. That involves IX. It will give you an extra equation, okay? But the thing is, if I write that one, let me write that one.
But
Let me write it. So 10 minus V3 over 8 plus 10 minus V2 over 19 plus IX is equal to 0, right? 1 equation, 2 equation, 3 equation, 4 equation, and 5 equation. I need to get rid of 2 of them. Can I do that? Yes. I mean, which ones are easy to substitute and get rid of?
third one, 3 and 4.
This one and this one probably are the easiest one to get rid of. Did that make sense to everyone? Then you will end up with 3 equations and 3 unknowns. Okay. Let me see. Which ones is... Okay, now, let me get to the final answer. Now, after we do this, what do we find? We find all the voltages, right? Because we're doing nodal. We find all the voltages. Now, which elements should we be worried about? The power supply by the dependent current source, this guy, right? So after we find all the voltages, we have the voltage across this thing, right? Which is V2 minus 0, V2. So we have that. And what is the current? 2 Vy. So if you solve the voltage, if you have the voltages, you can also find Vy, and then you can multiply them and find the power. Is it absorbed or supplied? Supplied. So the way the voltage should be is right there. Yeah.
Could you do mesh?
Yes, I'm gonna do mesh next. I1, I2, I3, and 3 amps, right? So how should I write the KVLs? Should I write one around I1 or no? No. Why? It's a super mesh. Write one around this. 14I1 plus 4IX plus 19 times I3 minus I2 plus 10 is equal to 0. That's one equation. Can I write one around I2? Yes. Negative 4IX plus 9I2 plus 8 I2 minus 3 plus 19 I2 minus I3 is equal to 0. That's my second equation. But I have 1, 2, 3, and 4. So I need more. Look inside the supermesh. What is I3 minus I1? Is equal to 2 Vy. And what else is involved? So we need equations about Vy. How many equations, how many unknowns do I have? 1, 2, 3, 4, 5, right? I need 2 more equations. Where are the 2 more equations?
IX equal to I3?
No. Ix is? That's the 4th equation. What is the 5th equation?
Would you write one for the 3 amp mesh still, because we have I2 and I3 in here?
Okay. But you don't know the voltage across the 3 amps, right? Do you see where Vi is? Can you show me where Vi is? Vi. Between those 2 nodes, right? Is there any way I can involve it in my equations? Negative Vy plus 8 times I2 minus 3 plus 19 times I2 minus I3 equal to 0. 1, 2, 3, 4, 5 equation, 5 unknowns. You can get rid of 2 of them. See, 1, 2, 3, 4, 5. It's better to get rid of these 2 again. So you will end up 3 equations, 3 unknowns, and you can answer. Okay? As I said it, 31 is the last question, and it's usually the hardest one. Yes?
So when doing mesh, you can, doing that over VY, you wouldn't have to make another, or you don't have to make a I5.
No, because that's not a new mesh. That's just some extra equation for me,
Okay.
right? Remember, whenever you're missing equations and you're trying to find them, focus on the variable and where they are. For example, the variable I1, we already did a mesh. I1 and I3, they make a super mesh. We already wrote one equation for them. We did one equation for I2. We did one equation for IX. The only thing that we haven't talked about is VY, or haven't written anything about. That's why I went to that one. The important part here is that I want you to focus on these 2 equations. Okay, these 2 extra equations. Where do those come from? IX, I3 minus 3. Look here. See, I'm focusing on where IX is, not on where IX is being used. See? That voltage source is where IX is being used. Here is where IX is. That's where it can help me to write extra equations. The same for VY. Done? Should I stop?